The R-squared is a measure of the goodness of fit, or the explanatory power. It is sometimes called the coefficient of determination. It captures how much variation in the outcome variable y can be explained by the explanatory variables x in the model. R-squared equals the explained sum of squares, SSE, divided by the total sum of squares, SST. The numerator, SSE, is a measure of variation in the fit value, y hat. That is, it captures the variation due to the explanatory variables. The denominator, SST, is the total variation in y. R-squared is the ratio of the explained variation compared to the total variation. It can be interpreted as the fraction of the sample variation in y that is explained by x. Since the total sum of squares, SST, equals the explained sum of squares, SSE, plus the residual sum of squares, SSR, we can write R-squared as 1 minus the residual sum of squares divided by the total sum of squares. For the estimation equation y equals y hat plus mu hat, the definitions of the SST, SSE, and SSR are as follows. Although we can calculate the R-squared manually, statistics software usually reports it after regression. Here's an example of the demand for ecologically friendly apples. We regress the quantity demanded on the prices of ecologically friendly apples and the prices of regular apples. Stata reports the R-squared 0.0364, which means only 3.6% of the variation in the quantity demanded for the ecologically friendly apples can be explained by the own prices and the cross prices.